Okay, this is NCERT current electricity 10th question. In a meter bridge shown below, the balance point found to be of 39.5 centimeter from the end A. Okay, here meter bridge having two ends na, A and B. When the resistor Y is of 12.5 ohms, determine of X. Actually what we can find out at X. Y are connections between resistors in Wheatstone bridge or meter bridge. Already we are discussing what is the Wheatstone bridge. This thing only. Balancing means P by Q equal to R by S. Here also you can see here like a X is the one resistance, Y is the one resistance, and below is the here balancing point. This is means where it is galvanometer is showing of null deflection. This is third resistance, this is fourth. Okay. Then actually here Y is given, we can find out it X. X is how much? Okay. And in this second question also it is asking determine the balance point of the bridge above if X and Y interchange. X and Y interchange. Here Y is there. We can write here in the place X plus Y and Y plus X. Then what happen? We can see. And the third question, what happen if the galvanometer and cell are interchanging at the balance point of the bridge? Would the galvanometer show any current? Okay, here is a cell. This is the galvanometer. Then what happen if it between we can change here galvanometer and we can place here battery. So is the first question is the length is given first balancing point 39.5 centimeters. Y resistance 12.5 ohms. Then here already one formula like a this Wheatstone bridge only P by Q equal to R by S, like X by Y equal to L by 100 minus L. So I am simplified, then I got X is the main factor, then L by 100 minus L into Y. I substitute above equations X equal to 39.5 by 100 minus 39.5 into 12.5. Then simple calculation you can do. You will get X equal to 8.2 ohms. Okay, 8.2 ohms. Same in second question according to the equation means above is given. If X and Y are interchanging, what happened? New length means L dash equal to we can 100 minus L we can do. Means first balancing point what is that? 39.5 L. So when we are subtract this one, then new length it will come 60.5 centimeters. In the C question, yeah, the interchanging of the cell and galvanometer does not affect the balance point. Okay, does not affect the balance point. No current will flow through a galvanometer. Galvanometer actually it is a device to detect the feeble current, means very small currents, and it also showing of direction. Okay, 11th question we can see a storage battery of EMF 8 volts and internal resistance 0.5 ohms is being charged by 120 volts DC supply using a series resistor of 15.5 ohms. What is the terminal voltage? What is the terminal voltage? Means end in battery or cell end parts how much voltage is there, that is only called terminal voltage of the battery. Drawing charging. What is the purpose of having a sense resistor in the charging circuit. See here, it is given the EMF of cell 8 volts, that cell internal resistance 0.5 ohms are equal to 15 ohms. Then we find out in that new resistance in the battery. Okay, that is R dash equal to this and means this resistance and cell internal resistance, it is connected in series. That's why already we know R is equal to R1 plus R2. Like this 15.5 plus 0.5, I got 16 ohms. Then actually EMF is given cell E equal to 8 volts. But new EMF, okay, means the total of circuit is calculated. E dash 120 is given. 120 minus 8, we will get 112 volts. This is battery EMF opposing supply EMF. Okay, means here what is the change in current? What is the change in current? That is I. Change in current formula already we know, E by R. Okay, E by R dash. Okay, already we are find out in R dash. That is 112 by 16. Means we will get 7 amperes. Then actually what we are find out in terminal voltage. What is the formula? E plus IR. Already we get E equal to 8 plus I equal to 7 amps and R equal to internal resistance 0.5. So this it calculated means we get 11.5 volts of terminal voltage. 12th question we say, in a potentiometer arrangement, a cell of EMF 1.25 volts gives a balance point, shifts to 63.0 centimeter. What is the EMF? What is the EMF of the second cell? Actually, it comes potentiometer. It is having two combination of circuits, primary circuit and secondary circuit. In secondary cell means secondary circuit, we can find out it. Okay, here L1 is given 35 centimeters, L2 is given 63 centimeters. Already we know one formula for potentiometer, E2 by E1 equal to L2 by L1. So second cell we want, that's why I am taking that main factor of the E2, then L2 by L1 into E. So E2 equal to just above data I substitute in the formula 63 by 35 into 1.25. Then we will get 2.25 volts. That is the number of density of free electrons in a copper conductor estimated in example 3.1. Is 8.5 into 10 to the power of 28 meter cube. How long does an electron take to drift from one end of a wire 3 meters long to its other end? The area of cross section of the wire is 2.0 into 10 to the power of minus 6 meter square, and it is carrying a current of 3 amperes. So in this we can see here length of the copper wire is given 3 meters. Area of cross section of the wire is given, that is 2 into 10 to the power of minus 6 meter square. And number density of free electron in a copper conductor n equal to 8.5 into 10 to the power of 28 meter cube. Current carried by the wire, that is 3 amperes. So this relevant, we have one formula. That is I equal to NEAVD. Okay. Here E means what is that? Electron charge. 1.6 into 10 to the power of minus 19 coulombs. And Vd means drift velocity. One formula is there, that is L by 2. So I substitute above I equal to N into A. Vd place I replaced L by T. So T equal to N into E into A into L by I. Then above data I mentioned here number of free electrons and electron charge and area of cross section into length by current 3. So total we are doing that simple calculation. Finally we get T equal to 2.72 into 10 to the power of 4 seconds. 14th question. The earth surface as negative surface charge density of 10 to the power of minus 19 centimeter square. The potential differences of 400 kilowatts between the top of the atmosphere and the surface resolves due to the low conductivity of lower atmosphere in a current of only 1800 ampere over the entire globe. If there were no mechanism of sustaining atmospheric electric field, how much time roughly we can find out it would be required to neutralize the earth surface. This never happens. Okay, this is never happens in practice because this is no mechanism to replenish electric charges, namely the continental thunderstorms and lightning in different parts of the globe. Here it is mentioned radius of the earth 6.3 into 10 to the power of 6 meters. So that is, here is given data r equal to that radius of earth 6.3 into 10 to the power of minus 6 and this surface density 10 to the power of minus 9 centimeter square. Current is given 1800 amperes. And here that area means what is the formula here? 4 pi r square. Then the charge density, it is occupied in this Q equal to sigma A. So here I equal to Q by T. Already we know formula. So we can find out it actually time. So I replaced Q by I in Q by I. So T equal to sigma A by I. So A equal to that 4 pi r square. Sigma into 4 pi r square by I. Then above data I mentioned here that sigma equal to 10 to the power of minus 9 into 4 phi equal to 3.14 into that r square 6.37 into 10 to the power of 6 whole square by I means that is current 1800. So total we can do simple calculation, then we will get that time 283.1 seconds. 15th question here is having two questions. 6 lead acid type secondary cells each of EMF 2 volts and internal resistance 0.015 ohms are joined in series to provide a supply to resistance of 8.5 ohms. What are the current drawn from the supply? Its temperature terminal voltage means V only. So one more question. A secondary cell after long use has an EMF of 1.9 volts, okay, and a large internal resistance of 380 ohms. What maximum current can be drawn from the cell? Could the cell drive the starting motor of a car? So in this, as for data is given, number of secondary cells that is 6, and EMF of the secondary cell it is given 2 volts. Resistance of the resistor, okay, internal resistance, that is 0.015 ohms. Resistance of the resistance joined in the series are equal to 8.5 ohms. Then we know one formula, I equal to Ne by R plus Nr. N means number of cells 6, that E equal to EMF of cell secondary cell, that is 2. R means that resistor it is connected into series, that's why 8.5 plus again it is number of cells 6 and internal resistance 0.015. Then simple calculation we can do. That current it is coming 1.39 amperes. Actually we want terminal voltage V equal to IR. So current already we get 1.39 into that resistor 8.5. Simple calculation to multiply it, you will get 11.81 volts. And the second question, actually we are find out in here maximum current I max equal to E by R, that E equal to 1.9, R equal to internal resistance 380 is given, then 1.9 by 380 we will get 0.005 amperes. A large current it is approximately 100 amperes is required to motor starts for a few seconds, so it cannot be used in a car.